So children, today we are going to discuss about aluminium extraction. Aluminium extraction. Okay. Basically, children, if you see seriously, aluminium, what is the symbol of aluminium? Al. Okay. And if you see atomic number of aluminium is 32 and mass number is 27. Okay, girls. If you see there its color, normally it will be silvery white color. And I was telling you when I told also it was silvery white metal. And I told you, what did I say? I told that it will not corrode. Why it won't corrode? Because aluminum has property of forming oxide layer around it, which prevents further combustion, further corrosion. Okay, so the main ore of aluminum is bauxite. The main ore of aluminum is bauxite. Okay, and the formula of bauxite is Al2O3 dot 2H2, where 2H2 is called water of crystallization. 2H2 is called as water of crystallization. This presence of two water molecules does not make it wet. Remember, it will not make it wet. So, and what is the extraction of aluminum and all these things by and the enrichment? It's called Bayer's process, and the entire extraction of aluminum was discovered by Hall and Heroult. Hall and Heroult. So entire procedure is called as Hall and Heroult process. Hall and Heroult process. As we discussed in metallurgy, what are the 4 steps of extraction, children? 4 steps of extraction is enrichment, oxidation, extraction, refine. So what is the funniest thing is enrichment is done by Bayer's process that we will discuss now. Enrichment is done by Bayer's process. Oxidation no need because it is already oxide. What is our aim of oxidation? To convert the ores into oxide. Already it is oxide only, so no need. And it can be reduced by reducing agent like coke. If you want to remove the oxygen, if you want to remove this oxygen, you put some like coke. It will take the and refining is done later. Okay, and refining is also done by Hoops process. Children, Hoops process is there, and that is how refining is done. So now coming to enrichment, children. Enrichment means like how do you enrich alumina? That is the important thing. Listen carefully, children. No? Listen carefully. So how do we enrichment? Enrichment is done means see here normally. Bauxite is normally it is first it is broken into pieces. After broken into pieces, it is heated under high pressure in presence of caustic soda. What is caustic soda? NaOH. Okay, I'm saying first they will take alumina. Alumina they will take. Okay, and to this they will add alumina. To this, okay, alumina just write Al2O3. Don't get confusion. Alumina Al2O3 right. Okay, to this alumina, what they will add, children, to this alumina, okay, alumina dot, okay, 2H2O, they add caustic soda, NaOH, caustic soda, okay, and it is after finally it is powdered, it is heated at 140 to 150 degrees, okay, 140 to 150 degrees, it is heated, and this process is called as with this is called leeching. What is it called? Leeching means when this powder is heated with NaOH, it is called leeching, and heating at a high temperature and pressure. And at this temperature, you get NaAlO2 plus H2O. Okay, normal reaction. If I want me to write, children, Al2O3 plus NaOH. Children, whether you remember or not, always remember Al2O3 is amphoteric oxide. What is amphoteric oxide? Means amphoteric oxide is that oxide which can react with both acid and base. So with acid it can react, with base also it can react. So Al2O3 reacts with NaOH, caustic soda, and forms NaAlO2 plus H2O. Let me balance 2 aluminiums, 2 sodiums, and how many oxygens? 2 plus 3, 5, H2 hydrogens are H2. Okay, if ever you didn't understand what I'm saying, take alumina and heat it with caustic soda. What do you get? NaAlO2 plus H2O. Okay, this is called sodium aluminate. What is it called, children? Sodium aluminate. What is it called? Sodium aluminate. NaAlO2. Okay, children. Now they will take NaAlO2. They will mix water, children. Okay, see here, children. Al2O3 plus NaOH. What you are getting? This is only still now we are in extraction mission. I mean to say enrichment only. Plus H2O. Okay. Now take NaAlO2, children. Take NaAlO2. Add some water. When you add some water, what you will get, children? NaOH plus Al2 Now take this aluminum hydroxide and heat it, children. Just heat it. At 1000 degrees centigrade, you heat it, children. You get Al2O3 plus H2O. This is Bayer's process, children. This entire procedure is called Bayer. 3 steps. Try to remember there's 3 steps, children. Okay, I didn't balance the reactions. You have to balance the reaction. So first you take alumina. Okay, you are reacting with NaOH. You are getting NaNO2 plus H2. Okay, children. When this procedure is occurring, a red mud is evolved, children. Red mud consists of ferric oxide, Fe2O3 mud, and some sand, and all of them are removed by filtration when you are doing this process. Okay, so when you are doing this process, red mud, sand, all those are removed, and you are doing enrichment. This enrichment process is called Bayer's process. First step is over. Second step is to convert into oxide. No need to convert into oxide because already it is oxide. Third step is extraction. Extraction is done by all and heroult process. In heroult process, I will tell you, children, that one. First, you should be perfect. You should be perfect with Bayer's process. What is Bayer's process? Take alumina, heat with sodium hydroxide. You'll get sodium aluminate plus water. Take sodium aluminate and wash it with water. You'll get NaOH and ALOH taken place. Remove NaOH and take ALOH taken place aluminum hydroxide, children. Okay. So what happens when you are taking this and you try at 1000 degrees centigrade, you'll get alumina and water. Water is going away. This is now enriched ore. No need of second step. Go for directly third step. So Bayer's process is over. Never forget with 3 reactions. 3 reactions, Bayer's process. Okay. And what are the impurities you are getting? Red mud and Fe2O3 and some sand particles are coming. And this process is called leeching. What is meant by leeching? Leeching means what, children? Leeching means heating the ore under pressure. Okay, for 2 to 8 hours or 10 hours, 140 to 150 degrees. Heating the ore under pressure for 8 hours at 140 to 150 degrees is called leaching. Okay, so Bayer's process is over. Again, during when I'm revising, I will tell you all this, children. Now, next step, Hall and Heroults process. Means second step we are skipping the, children. Third step we are going extraction of metal from its oxide. Hall and Heroults process. Hall and Heroults process. Okay, children. Here, electrolytic tank will be there, children. In electrolytic tank, what will take means here normally, children, along with the alumina, children, we will add some cryolite. What is cryolite? I will tell you. What is cryolite? I will tell you. Along with the cryolite, children, and we will add some flourospar. Flourospar. Okay. Then you will ask, sir, why along with the cryolite alumina, why we should add cryolite and flourospar? Why means, children, the temperature at which this alumina melt is approximately 2050 degrees centigrade. Okay, what cryolite will do means this cryolite will lower the temperature from 2050 to 950 degrees and by increases the conductivity. Try to understand. Aluminum oxide, okay, it will melting point is 2050. This cryolite, what is cryolite means? Na3Al6. What is fluorospar? CaF2. Try to understand, children. You should understand. One more question they will ask. Why cryolite is added? Why cryolite is added? It will decrease the melting point from alumina from 2050 to 950, and also it increases its conductivity. It increases its conductivity. This is number one. Now, why fluorospar is added to aluminum oxide? Fluorospar is added because it acts as a good solvent. It will make it to dissolve. It acts as a good solvent and also increases. This also increases conductivity. This also increases conductivity. And also, children, we will add some powdered coke. I told you, do you remember, children, down metals will go for direct heating. Middle metals heating in presence of reducing agent like coke. Upper metals electrolysis. I hope you remember, children, electrolysis, down metals direct heating. Middle metals heat in presence of reducing agent like coke. And upper metals electrolysis. Because it is middle metal, we'll put some powdered coke also, children. What is the function of coke? Okay, it reduces heat loss by radiation and prevents the burning of anode also. It prevents the burning of anode. Okay, children, it prevents the burning of anode also, and it reduces the heat loss by radiation. So now, neatly I will say, children. So what we are taking, children? Aluminum oxide. To this we are adding Na3Al6 cryolite. To this we are adding fluorospar CaF2. To this we are adding some amount of coke. Okay, children. Now we will pass the current, children. When you pass the current, Na3Al6 is there, and CaF2 also is there in the reaction mixture, and aluminium oxide is also there in the reaction mixture. All of them, when you are passing current, children, when you are passing current, it decomposes into Na plus Al plus 3 and F minus 1. Here how many are there? 6. Here how many are there? Na3 Al 6. 1. Here how many sodiums are there? 3 on passing current. And this breaks up into Ca plus 2 F minus 1. How many fluorines are there? 2. And this breaks up into Al plus 3. How many are there? 2 are there. And how many are there? O minus 2. This is on passing current, it happens. On passing current, try to understand. On passing current, cryolite breaks into 3 sodium ions, aluminium ions, and fluoride ions. Fluorospar breaks up into calcium ions and fluoride ions. Aluminum oxide breaks up into aluminium ions and oxide ions. Now, to the cathode. Okay, to the cathode. What will take cathode means, children? Some carbon graphite rod will take, children. To the cathode, who will take? Who will go normally? Okay, first let me discuss anode, children. Then you will understand. Normally to the anode, who will go, children? Oxygen will go. Where is oxygen? This one. 3O minus 2 will go, children, and it will give 6 electrons and forms oxygen gas and escapes into the atmosphere. Escapes into the atmosphere because here 3 are there. If you want, you put 3, right? If you want, you put 3, right? Okay, children. And this 6 electrons, who will take 2 aluminiums? Who will go to cathode, children? Who will go to cathode? Plus will go to cathode. This is also there. No, this is also there. No, sir. You may ask. Yes, children. 3 of them will go, but aluminium will deposit 2Al plus 3, and it takes the 6 electrons and forms aluminium metal. Aluminium metal. Okay, children. So why aluminium? Because it is low in electrochemical series. Preferentially, it will go to cathode. Children, we have a series, children. When sodium and calcium and aluminium are running towards cathode, aluminium will be discharged because it is low in the activity series. Whichever is low in the activity series, that will be discharged preferentially. Okay, children. So cryolite, fluorospar, alumina are decomposing into ions, and at anode who is going? Oxide is going. At cathode who is going? Aluminiums are going. This is liberating 6 electrons. That 6 electrons aluminium. Aluminium metal we have got over. That's all. We got aluminium metal. Okay, children. So what happens? This reaction keeps on continuing, children, and carbon also reacting with oxygen and form carbon monoxide. Carbon monoxide continuously reacts to form carbon dioxide. What happens? Alumina keeps on occurring, and suppose voltage is increasing in this electrolytic cell. Voltage is increasing in the electrolytic cell. What happens means, then fresh alumina is added, and you will get whatever you are getting here, 99.8% pure aluminum you get. This is second procedure, children. What is the second procedure? It's called Hall and Heroults process. Okay, children. This are breaking, but they won't involve in the reaction. This are breaking, but they won't involve in the reaction. Why means aluminium is low in the series. Electrochemical series, potassium, sodium, calcium, magnesium, iron. Like aluminium will be discharged preferentially than sodium and calcium. This is second. Again, I will revise. Don't worry, children. This is second. And now third, children. Now you got aluminium, children. Okay. What is our first step? Enrichment. Enrichment is done by Bayer's process. What is second step? Oxidation. No need of oxidation because it is already oxidized. What is third step? Extraction. Extraction is done by Hall and Heroults process. Last step is refining. Electrolytic refining. This is done by Hooke's process. Okay, children. This is done by Hooke's process. Here, what happens means, same, children. Here, what happens? Hooke's process. Okay. So, what will do, children? Same procedure. I told many times: anode, cathode, electrolyte. Anode, cathode, and electrolyte. What should be the anode, children? What will be the anode normally? Anode should be impure aluminum. We have to take. Cathode, pure aluminum. We should take. Electrolyte, salt of any aluminum. Salt of the any aluminum. Your wish, children. Any aluminum sulfate, aluminum chloride, or anything molten fluoride. Anything. Something you will take, children. Okay. So when you start passing current, children. When you start passing current, okay. This is anode. This is cathode. Anode means connected to positive terminal. Cathode means connected to negative terminal, and some aluminum fluoride or something is taken, children, on passing the current. From here, pure aluminum, and from here also pure aluminum comes and settles on the cathode. Same, I told you discuss. Okay, so what happens at anode, children? At anode, okay, it will lose 3 electrons and forms Al plus 3 at anode, because Anode is impure aluminium. From impure aluminium, all impurities it will leave, and aluminium loses 3 electrons and forms aluminium plus 3. Okay, and at cathode, it will go at cathode. The aluminium plus 3 takes 3 electrons at cathode, and you get pure aluminium here. So normally what happens when you pass current, children, aluminium from the middle layer, aluminium fluoride will be there, aluminium fluoride will be there, aluminium from the middle go to the top layer, and also at the same time, and pure aluminium will be tapped on the top of this, and you will be getting a pure aluminium. Okay, anode is impure, cathode is pure, electrolyte is salt of the metal to be purified. Okay, again I'm saying slowly, listen, children. When you pass current, children, see here, when you pass current, I will show you 1 second. Neatly, I will show you. Again, I will reverse, children. Don't worry. Again, I will reverse. Here, children, like this, it will be there. Layers. Okay, 1, 2, 3. Okay, when you pass current, children, what happens? Aluminium from middle layer, aluminium fluorides will be there. No? Aluminium from middle layer passes to the top layer. Okay, and at the same time, from lower layer, an equivalent amount shift to the top layer. At the same time, an equivalent from top layer shifts to the lower layer, and from lower layer, something will come middle layer. Okay, last time I'm saying, try to understand, children. When you pass current, aluminium from the middle layer goes to the aluminium top layer. At the same time, equivalent amount of it shifts from lower layer to middle layer. Okay, lower layer to middle layer, and from here to here, it will go, okay, up to down it won't come, children. From here it will go here, and pure aluminium, and like that aluminium will be forming here, and you'll keep on tracking that, children. That is called refining of aluminium. Okay, small discussion, children. Again, just small. I will help you to understand. First is Bayer's process. In Bayer's process, what you're doing, children? First step, extraction, no oxidation, enrichment, extraction, refining. Okay. In enrichment, what you're taking aluminium oxide, just you're adding sodium hydroxide. When you add sodium hydroxide, you should remember this NaAlO2 plus H2O. There is no other alternative. Okay, take NaAlO2, children, add water. When you add water, what you get? NaOH plus AlOH taken thrice. Take that AlOH taken thrice and heat it, children. And this is called leeching, children. Leeching. Okay, Al2O3 plus H2O. This is now all the impurities are gone. And in extraction, what you do, children? In extraction, along with the aluminum oxide, you add cryolite and flourospar. And when it is passed, current is passed, here you will get aluminum and oxygen ions are getting. Okay. Al plus 3 is coming and O minus 2 is coming. O minus 2 will give 2 electrons and forms oxygen gas, and aluminium will take 6 electrons taken by 3 aluminiums, 3 oxygens. So 6 electrons it will take, 6 electrons it will take and forms aluminium ion, and later aluminum metal you are getting, and in aluminium last process, Hoops process is there. In Hoops process, what you will do, children? In Hoops process, you will take a mixture of aluminium form, mixture in layer, bottom layer, what will be there, children? Bottom layer, carbon lining will be there. Carbon lining, and this serves as anode. Okay, and pure carbon will be there, children. Pure molten aluminium on the top layer, children. Pure aluminium on the top layer, which serves as a cathode, children. Which serves as a cathode. And middle layer consists of salts of aluminum. Again, I'm saying, children, 3 layers: down layer, middle layer, upper layer. This consists of carbon, which serves as anode. This has top layer has pure aluminium, which serves as cathode. So when you pass current, aluminium from the middle layer goes to the pure aluminium, and same amount of aluminium from the down layer comes here. Okay, because this is also aluminium only. This is electrolyte. This is cathode. Anode, electrolyte, cathode. Anode, electrolyte, cathode. From anode, pure aluminium is coming to middle layer. From middle layer, pure aluminium is going to pure aluminium. Pure aluminium is going to pure aluminium. No problem with the MO. This is how it is done. Bayer's process, Hall's and Heroults process, Hoops process. First one is Bayer's process. Second one is Hall's and Heroults process, and third one is Hoops process. Okay, in Hooke's process, down is anode, middle is electrolyte, top is cathode. And in Hall's and Heroults process, even though cryolite and flourospar are there, aluminum only will go because preferential discharge will be there for aluminum. And in Bayes process, what we are taking NaOH, we are leaching it. We are getting sodium aluminate. Sodium aluminate, we are adding water, you get sodium hydroxide. And to the aluminum hydroxide, we are heating it, you get aluminum oxide water. This process is called leaching. This is called enrichment, this is called extraction, this is called refinement. Here, 3 days, you don't forget children. That's it. Okay, and anyone have any doubt, you ask me.